Polyatomic ions. What are polyatomic ions? So polyatomic ions are ions composed of two or more atoms bonded together with an overall positive or negative charge. Within the polyatomic ion itself, you may have covalent bonds, something we will discuss soon in coming videos. But disregarding that, here are some of the formulas. Ammonium, this is known as the ammonium ion, which has nitrogen and 4 hydrogens. That's the ratio in which they are combining. They are bonded together, and you have a plus charge. Now when it's just plus, it means 1 plus. A total charge on this entire ion is 1 plus. This is not a compound by itself. A compound has to be neutral. We saw in the previous examples how ionic compounds were made when one ion combined with another ion, and as a whole it had no charge on it. Well, since there is a charge on this, it cannot be considered a compound, but it can form compounds, as we'll soon see. Here is another example of a polyatomic ion. This is known as a polyatomic anion with a 2 minus charge. It's called sulfate. Now, there are many polyatomic ions, and most of them are negatively charged, as you will see, with some exceptions shown here: hydronium ion H3O plus and ammonium ion. The rest are negatively charged. And why are we learning about them? Because they are extremely important to science, extremely important in chemistry. As a matter of fact, if you were to look at some of your products, your health products, your supermarket products, and look at the ingredient list, you will find many of this listed over there. For example, you can find sulfates on a shampoo bottle, and you may have heard of cyanide. Phosphates are found in fertilizer. If you know the marble, the stone marble, it's a calcium carbonate. If you know baking soda, it contains bicarbonate, for example. So here are a lot of them. Peroxide, you may have heard of, is something that removes stains from teeth that dentists use. Now, of all of this, I expect you to know a few of them, and let's go over which ones they are. I expect you to know by heart the formula as well as the name: nitrite, nitrate, sulfite, sulfate, hydroxide, cyanide, phosphate, and carbonate. So those are the ones I expect you to memorize by heart, because for the rest I may give you the formula and then you can manipulate the formulas, or I may give you the name and the formula, but regardless, you will be not required to memorize the names of the others or the formulas, but the ones that I just mentioned, go over that list again and memorize their names as well as formulas. Now let's see what we can do with this. We can make compounds out of them. Now these compounds are slightly different from the previous ones. The previous ionic compounds were made up of monoatomic ions, a positively charged followed by the negatively charged. Similarly, we will have the positively charged polyatomic ion first, followed by the negatively charged, and we can combine the polyatomic ions with monoatomic ions, such as ammonium with chlorine here. Ammonium, if you go and look at that table, has a charge of NH4 1 plus. Chlorine has a charge of 1 minus. What would be the name of this compound? The name would be exactly as you have done in the simple monoatomic ionic name versions, where you took the first cation name as it is, and for the anion you put IDE. But when it comes to polyatomic anions, you keep their names as given to you in this list here. So let's see what the names will be. Ammonium, keep it as it is, and this becomes IDE, monoatomic, so chloride, ammonium chloride. Now in the list, this is called sulfate, and this is barium, a monoatomic anion with a 2 plus charge, and a polyatomic monoatomic cation with a 2 plus charge, and a polyatomic anion with a 2 minus charge. You crisscross them, you have 2 bariums, 2 sulfates, but the simplest whole number ratio becomes BaSO4. This is called barium sulfate. Here a nitrate has 1 minus charge crisscross here. Iron comes in variable charges, as we learned in the previous video for transition metals. So in this case, what is the charge on this ion? Is it 1 plus, is it 2 plus, or is it 3 plus? Since we would crisscross that charge over to the other side and we see a 3 here applied to this entire nitrate, we know this 3 originally belonged as a charge on iron. So the name of this compound would be iron parenthesis 3 nitrate, iron 3 nitrate. What about this compound? What does HCO3 represent? HCO3 given to us here is called bicarbonate with a 1 minus charge. Now copper also is a copper is a transition metal with 1 plus or 2 plus possibility. What is the one that's found here? Since we see just HCO3 without any parentheses and any number, that means there is just a 1 here. That 1 came from here, so this is copper 1 bicarbonate. And lastly here you have calcium hydroxide. This is how you name these compounds, and it's very straightforward. You may be given the formula and asked the name, as you see here, or you may be given the name and asked to come up with the formula, and you should be able to do both. And we have already discussed how to name ionic compounds. But here are some more examples. Sodium sulfate. Now we have a name. Can we come up with the formula? I asked you to memorize sulfate, and sulfate is SO4 with a what charge? 2 minus charge. Let's go to the table of polyatomic ions and have a look. SO4 with a 2 minus charge, that's sulfate. So what would be the formula of this compound? That 2 minus would crisscross over to sodium. Sodium only has a charge of 1 plus, crisscross over there. So what would be the formula? It would be Na2 as a subscript, SO4. So come up with the formulas of the other 3 compounds, and notice here how sulfate is different from sulfide. There is sulfate, there is sulfite, F-I-T-E, and then there is sulfide. Sulfide is the only monoatomic one with an S and a 2 minus charge. Sulfate is SO4 with a 2 minus charge, and sulfite, F-I-T-E, is an SO3 with a 2 minus charge. Keep that in mind and practice some more with these formulas, with these names, and come up with the formulas.